So Jennifer Pruitt is going to solve that mystery for you. And she's going to tell us a little bit about the space station. Jennifer, it's all you.
Hi guys, good to have you here. Like you mentioned, I'm Jennifer Pruitt. I've worked here for several years here at Marshall. Most of my career has been solely on ECLSS. ECLSS is environmental control and life support systems. So there's a lot that's in there, and that's why I like to bring this little display, because it kind of helps show all the different systems that are included and just a little bit of how everything works together. Our biggest goal is keeping astronauts alive. So you need that if you're going to send people to space, and that's why this type of hardware is so critical. And also why it's really exciting to work on, because it's something that every day you come into work knowing that your job is important. So that's how we've had people on a space station for, I think it's over 14 years continually now. And that's thanks to systems like these that we're able to do things like that. If we're going to have a habitat on Mars or Moon or anywhere there's people, we need these kind of systems. Robots do great jobs, when they go out and explore, but to send people there and have that human element, life support is critical. So here, this is our little overall at the center, is our people, and that's how we like to think of our jobs. The people are at the center of what we do. So we work really closely with the people at Johnson. Everything that's on here is not something that Marshall does necessarily. It's kind of, there's a big ECLSS community, and we have our own certain parts that we are responsible for. So at Johnson, they look at things like the fire detection suppression. That's something else. If we're going to have a fire in a can that you have oxygen, pumping into, how do you deal with a fire? So every system that's on station has to worry about things like that, just to have a plan. So the people at Johnson do things like that. Also temperature, humidity control. We want the astronauts to be comfortable. We want them, their job is to do their job. Do the science, do the experiments, learn really cool things. So everyone's making sure that the temperatures, about 72, they can work in short sleeves and they're not worried about it's too hot, it's too cold, I'm uncomfortable. And then also the humidity, which I'll talk a little bit about as well. So again, people are at the center. You have all these different things affecting them. Water and air, is a lot of what we do. So things like waste management, a lot of this is, we are recyclers. We're trying to figure out how to use what we have and how to get what we need out of it. So things like waste management do factor into this. We think of all of this as kind of waste management. You have something that, like CO2 that you're breathing out, you need to figure out what to do with that because you can't let it build up in the air. But then there's also a whole bunch of logistics people that are at Johnson Space Center, and they are looking at all the just garbage, basically. If you didn't take your garbage out and put it out at the road and let them take it every week, your house would be pretty nasty. And that's what they're just living in this can. So there's the logistics people of trying to send up stuff that they need and get back things that they don't, so they have space and they're not just floating around in a bunch of foam that they don't need. Or you guys have seen the food, right, that they eat, and they're in those little plastic containers because they're dehydrated. So it's the same thing like camping. Every time you open one of those, you have another piece of garbage that you have to do something with. So there's a lot of that kind of stuff that is dealt with there. And then also there are some other things that we can't do anything with. For example, I think everyone poops. That's the kind of stuff that ECLSS is responsible for, biological waste as well. Right now, we don't do anything with that, so there is a system to dispose of all of that, because you definitely don't want that just sitting around the space station for a long time. So that's also factored in here. And I think there is some research at some places, not here at Marshall, but I think Ames was looking at some a while ago of, is there a way to use that for something? And have you guys seen the movie The Martian? So, can we plant with it? Things like that. That'll be really looking at going forward. But for space stations, since we're relatively close, we can have vehicles coming up and down more frequently than we would going to Mars. We can just dispose of things like that. So I'll talk a little bit about the air side here. Everyone breathes, right? Everyone farts? Yeah? Okay. So we have systems like the trace contaminant control. I mean, these are things that you might not really think of, but it's things that we have to think of because you have, say, 6 people in a can, and people stink. They just do. So there's systems to even deal with the bigger things I'll get to in a minute, but even the small things like that, trace contaminant control. How do you freshen up the air and make sure that anything doesn't continue to grow? So CO2 reduction. We breathe oxygen, we emit CO2. So whether it's a trace contaminant, whether it's CO2, any of those, you don't want it to build up in the air because then you could have astronauts passing out and worse. So that's why we have to have these systems to remove the CO2, to reduce it from the air, so that we can, get that oxygen and put that back out into the cabin, so that the astronauts, again, aren't worried about, I can't really breathe well. That should never be their concern. We also have the oxygen generation, and that will be mixed up with the water systems here. Basically, electrolysis, splitting that hydrogen and oxygen, putting that oxygen back out into the cabin. Nitrogen, also another concern. So there's a lot of these things. How do we keep it balanced will be a concern, obviously going to Mars as well. And there's a lot that's going on here. I'm not going to talk too deeply into it because that is not my area of expertise. I don't want to lie to you guys. But there's a lot of, the oxygen recovery right now on station is at about 50%. So that's okay. It's still doing its job, but especially when we go to Mars, we really need to start pushing that up. So our facilities here, our ECLSS facilities, are basically just big R&D labs. We have a big high bay, and there's lots of equipment scattered all over with these different systems that they're testing by itself to try to figure out what new technologies we can use to try to bump that oxygen recovery up. And then we also have an environmental chamber where we can take all of these different air systems. Basically, it's a module. You close the door, let it run, and you can simulate a habitat environment to see how everything works in conjunction to find out if you're going to have any other issues that you didn't expect. So there's a lot of work going on here since we really need that, try to get that other 50% of that oxygen back. So my expertise is really over here on the water side. I've been working on this for about 7 years. So, we all need air to breathe. We all know. We all need water, obviously. And, there's lots of work going into trying to send rovers and find water on Mars and asteroid and all these kind of things. And that's great. If we could find a water source where we send people, that'd be fantastic, because then you don't have to worry as much about some of these technologies maybe, or you can incorporate them in different ways. On station, we don't have any source. We're just floating in the cans. So we have to have these systems to deliver the clean water to the astronauts. So I have my little jars here. So there's 2 steps to the water recovery system. The first one is the urine recovery. So you'll see this nice little dark. If you look really close, you can kind of see some green. This isn't like astronauts have really bad issues in space and pee funny. Everyone pees, right? So we all know about this. So it shouldn't look like that. So that is because we have to, when the astronauts use the restroom and flush, it's mixed with flush water, kind of like our toilets have, and also a little bit of some acids. So you guys ever smell like a baby's diaper, kind of, ooh, yep, time to change. Not from the other side, but just from the urine. You can smell it's the urea breaking down into ammonia. And so we don't want our urine to start breaking down into other things and changing that chemical composition of it. So one thing that the acids do is to, we call it a pre-treatment. So if you see the pre-treat on there, the pre-treat's going to keep it stable. The other thing it's going to do, if you have any water sitting out for a long time, you see, pond scum, if it's just sitting there, you're going to start growing all kinds of fungal or bacterial growth. So it's also going to lower the pH so that nothing's growing in the system. Because when we have this water system, you do not want to have solids. It's designed for fluids. You start adding in, chunks of a fungus floating around, and you could be in for a bad day, and then how do you get it out of the system? So that's why this is the first step, kind of hit it right at the start, and it can go on. So all of that's in the toilet. There's actually 2 toilets on station. There's one on the US segment and one on the Russian. They're both the Russian design toilet. They just bought it from them. So that's what we have right now. So when one's down, they have another down. I don't think we've ever had both the toilets down at the same time, but that would be an interesting day, I imagine. So with our Russian toilets, this is what we get out of the toilet. They also remove the air, and then it gets sent to our system, and that's our NASA system. People have been here working at Marshall on this urine processor for 25 years. They're experts, and they're phenomenal to work with because they have such expertise. So they've been great to learn from, and you know, they know so much about it. So we get this black-green nasty water here. So what the urine processor is, that's the first step, the water recovery. So if you are on a desert island and you need water, you know, you have the ocean, but you can't drink it because it's salt water. That's basically what urine is. It's just water and salts for the most part. So the same way, if you're on that island and you need water and you had a way to make it boil, that is what you do. So it's a very physical process. It's obviously much more advanced and sophisticated, and it's dealing with fluid and microgravity, which is part of why it has to be so sophisticated. But basically what we're doing is we're boiling this urine, and we're collecting that good water, that good clean water that evaporates out. So at that point, it's very, very clean. There's probably a little bit of, you know, some trace contaminants of things. No one has ever drank that water at that stage. I think part of it too is even in testing, I think part of it's a mental thing, going straight from urine to water. There's a little bit of a, do you trust it? And so no one drinks it at this stage. The crew won't see it until it gets through the rest of the system. So we process our urine, and then the next part's the water recovery. It's the water processor. So we also have humidity condensate, which I kind of mentioned before. We deal with the temperature and the humidity. So the same way that you have your soda can and cold soda can, and you see the condensation around, we have cold plates. We're getting that condensation from the air. That water is being diverted to the water processor. So the second step has those 2 sources of water, the water from our urine, and then that humidity condensate that we're getting. So that's a very chemical system, the second part, because basically you already have water. You just are cleaning it up and making sure there's nothing. So there's several multifiltration beds. There's a catalytic oxidizer. And so by the time you're done, you have the purest water that you've ever seen. It is very clean. There's nothing in there. There's not the minerals and everything. Again, because the same way as we talked about here with the composition of the air, you don't want anything to build up. You don't want to have a bunch of minerals that are in there and can kind of crud up the system over time. So that's a very chemical system. By the time that's done, they put a little bit of iodine in at the end. And that's just to make sure, again, kind of the same way as the pre-treat. We don't want to have anything grow in it. So it's a microbial agent. Put that in there, but it comes back out before the crew drinks it. And they have their good, clean water. I know people have asked before, well, isn't that going to be like DI water and stuff's going to start leaching out? Yes, it could, but there is also, again, at Johnson, since they deal with the crew themselves, they have this whole army of people dealing with the medical and the food aspects of everything. And so, they know what they have with us, with our systems, and they make sure that, the crew is still getting everything they need to replenish that. So we're not, I mean, astronauts already have crazy stuff happen to them in orbit. You guys have, we've heard like their eyesight changes. The calcium leaches out of their bones, which is part of why they have to exercise so much. So really crazy stuff can happen, and actually some of it was back in 2009. Our system broke, and we weren't really sure what was going on, but all of a sudden the fluid stopped moving. And so we had to bring some hardware back down and figure out what was going on. Like I said, the calcium leaches out of their bones, and I don't know if no one ever thought, where does that calcium go if it's coming out of their body? Well, it turned out it was coming out in their urine. So that was something. So we have our ground test facility We have hardware that's just like it is up on station, and we have, you can go to the restrooms and donate to our cause. And so we're running with that, with just, our, for all intents and purposes, urine, which is now different because we didn't add in that extra calcium. So all the testing we had done, we were getting 85% of the water out. We're like, yeah, 85%, this is a great number. This is what we needed for the water balance, someone had decided. And also, again, remember, you can't get all of the water out. You're going to have some, because this is a system designed for fluid. So you can't evaporate it all out and then just have a bunch of salts stuck. So we were at 85%. Great. Things are going well. It stopped. We got it back, and there were these crystals of gypsum, like drywall, these pea crystals that we had. And that was when we started looking at it and realized, oh, we found the calcium. Because before we had these systems, went up in 2008, they were just throwing away the urine because there wasn't a system to do anything with it. So we found that out. We had to reduce the recovery. And that also led to, okay, this whole big project for, we know there's extra calcium. Now we know we have to change our tests. How much water can we get out? Because the problem was that these crystals were being made once you got to, I think it was like 75% of the water out, then you started having this precipitation. So we had to lower recovery, went through this big thing. Can we remove the calcium? No, that stuff doesn't work. Is there a sensor we can use? No, that doesn't work. What we ended up doing was actually changing the pre-treat because it had a sulfuric acid. And so what was happening was that sulfur was mixing with the calcium. So now it's a phosphoric acid. So you can get more of the water out before you start having that precipitation. So that actually just started. We sent that up last year, and we've been running with that, which is great because now we're able to get more of that water out. But that was a really good thing to learn on station. So station is great, being able to send experiments. Even this, I think of this as an experiment. I mean, it's a system, but Olive Station is an experiment to see how is it really going to work. So we were able to learn that, so now we don't have to figure that out on Mars. Oh, we found this thing. So, as best as we can, we love to run these, run them hard, but still with margin, right? Because we're NASA, so we like to have a little margin. But to learn that kind of stuff here. So Marshall and Johnson working together have done a lot to do this, and us as the hardware experts know a lot now. So going forward, looking for the exploration systems, what can we change to make these things more reliable? They're also, I think it's later this year. Is it later this year? They're sending up a brine processor. So what we have, this is the input to the urine processor. This is the output. So you can kind of see the ratio, the 85% recovery. This is the amount of waste you have, just proportionally. So you're still going to have this brine at the end. And again, there's a lot of water in here because we need to leave some. The brine processor is designed such that it doesn't need the fluid to move. You're able to just put the fluid in, it evaporates out the water, and then you can get this other 15% of the water and really get us towards that 100% recovery. For the water processor, it's basically, like I said, water in, water out. So that's like a 99.99% recovery. It's just those little trace things that you're getting out. We're down here at about 85 with the urine, so overall it's about a 92% recovery overall. So still much better than the oxygen, which is why this is a huge thing for us at Marshall, trying to figure out, okay, the water is doing good, could be better, right? Could get to that 100. And so we're looking at a lot of things, also reliability on both sides for going to Mars, because we're not going to have resupply missions like we do on ISS. So working on that, working on this, and so there's a lot of really exciting work in ECLSS coming up. If you guys get to talk to anyone else who works out here on the ECLSS, I'm sure they'd love to talk with you. Everyone's very passionate about this, because like I said, at the center of all of this is keeping our astronauts alive. There's a banner up in the high bay that says, "Keeping astronauts alive since 1973." And I love having that up there because I think that's just such a great mantra. Like every day is a good day as long as that's true for us. And we've met our goal, our vision. So that's a kind of an overall of all the systems and what we do here at Marshall. Do you guys have any questions about space station, living in space, life support? Yeah.
you're talking about recovering like 85% of the water from the urine. What about the human as a sort of processing plant? So like if I drink a liter of water, how much does a human excrete in terms of urine? Or is it different for every person? The thing is, like, the water is sort of energizing me. Like, food is the same thing, right? Like, you know, not really like garbage in, garbage out, but I mean, we eat food and some comes out, but some of it I use. So, what were you gonna say?
No, I'm sorry.
Yeah, so.
So in the human body, how much water
some of
comes
it's
in
gonna
and
go
water
out with
comes out?
sweat, some of it's gonna come out with me just talking, but some of that water, technically, if I sweat or if I talk, that's gonna go in the air and contribute to humidity.
Yes, it will,
And
yes.
so
That kind of
I'm
stuff's
just
also
kinda-
captured.
Like everything, like, cause it's a can, so it's all a closed system, so I'm just trying to think, like, has anybody done any studies on that?
I am not aware, but that doesn't mean it's not happening. And I guess I'm also trying to say, you know, you could probably go and look up what it is for a human body here on Earth, but I'm not sure if there's a difference when you're in this environment. Because we also capture some of the humidity, it can be a drier environment than it is here, especially in Alabama where you go outside and get a shower. So I'm not sure how to answer your question,
Yeah.
and I don't want to lie to you. So.
Yeah, because I've also heard that they do, when they go up into space, I forget which way it is, but they almost have to like drink like 2 gallons of saline or something before they come back to Earth, or vice versa.
I haven't heard that.
Because it's like the fluid, they have to like contribute to the fluid in the brain to keep the pressure on them or something like that.
That would probably be, if there's things like that going on, that would be more of the JSC human factors
Okay.
type thing. Whereas we here don't really, I guess, care. We know about, okay, astronauts need to drink 2 liters of water a day, like anyone else
space,
does
or
in
is
space. Well,
is it
both
different?
really, right? Who drinks 2 liters of water a day? Anyone? Okay. They need to, but especially for them because they are more prone to kidney stones because of the calcium issue. They need to drink that. So, I mean, I guess everything eventually goes in and out, but I'm not sure what the metabolic rates of that stuff are. But I'm sure there is someone looking at that. But we just say, what's the end result? How much urine are you putting out a day? About how much sweat from exercise. You know, we did several tests where we made an exercise room, basically a contained exercise room, and people loved it. It was great. They could get paid basically to go work out for an hour. And you know, we give them like Gatorade, and we gave them T-shirts, and they would go work out and then leave their T-shirt to collect the sweat off of those. And I think they'd like make a meal to kind of have that steam, things like that. So we have a baseline for what to expect. But yeah, I said we care about the end result. That stuff's probably the human
So
factor.
2 liters of water a day. So how much urine does a hundred? I mean, how much of urine does a human create per day?
I'm on it.
You're on it? Are you googling it right now?
Yes.
Google it. Yeah, that's absolutely. And it really does depend, because we don't, you know, we're not tracking uses per astronaut. Did you find an answer?
I found a chart.
You found a chart.
Breaks it
Fantastic.
down into urine, sweat, transpiration, expired air, and feces.
Yeah. You want to just send me that link?
Yeah. Can I just pass my phone
I
around?
look forward to your paper.
There's the iodine.
Yes.
In the water supply here in Huntsville, they add chlorine to kill microbes.
Oh, probably. Okay. Yeah.
But in your case, the iodine is extracted
Yes.
before it's given to the astronauts
Correct.
to drink?
Yeah, so at the end, they put a little bit in,
Yeah.
and then it goes to a storage tank, and then at the end of that storage tank,
That's the same purpose, though, to kill microbes?
yes, it is.
Okay.
It is.
But when they drink the water, they don't have anything like chlorine or any of those?
No, not that I'm aware of, it's just,
Okay.
it's just water. And they normally,
So it's
From
probably
what I've
better
heard-
water than we drink here in Huntsville?
oh, it is. Well, and that's what I think someone asked them one time what it tasted like, and said wet. It doesn't have a taste because there aren't those minerals and everything in there to give it a specific taste. But I've heard that they don't actually drink a lot of just straight water. In their, you seen like their drink pouches they have, their little silver drink pouches, and they have a straw on the end so they can hook the straw up to the water and fill it up. And inside the bags they send up, they'll send like tea or lemonade or something like that. So I've heard that they drink a lot of that. They have the new, the coffee, the espresso machine. Have you guys seen that? They made an espresso machine for, what's her name? Samantha, Christopher Eddy, yes, thank you. And so she was the Italian, and anyway, while she was up there, they made like a cup, right, to contain the espresso. So like an open cup, and the way it was designed to use the water to stay in there, and they could sip it. You have to look this up. This was a really, really neat thing that they did to try to, I think, probably make it a little bit more like home, and not so much of, just drinking out of the bags anymore.
So at the present time, solid waste is not treated in any way,
Correct.
just thrown over?
Yeah, they have, so the way that they actually do it is they have like, you'll make pancakes of it. So it's just funny. I wasn't here when they were doing it, but they actually were testing this here. You had to like go out into this little like trailer and get to use the bathroom. The things we do for testing, it's just, you kind of lose your filter when you're working here for a while. So you have like a layer, like a bag, and then you do your business, and then it like puts another bag and flattens it. And so I forget how many like levels, and then you just throw it all out.
So you're losing water there?
You are losing water. That's part of the loss.
You mean throw it out, like it's like ejected from
No. That would be space debris.
Right. That's what I was concerned about.
No, the way that we dispose of things is we put them on a vehicle that's either going to return to Earth, and then it'll get disposed of here, or one that will burn up on reentry.
Okay.
And so next time you see a shooting star, you go, yeah. I mean, if you were to do that with like urine, you would have like pea crystals, like all around the station, and we wouldn't have that. And there is so much. That's why there's a whole army of people that deal with all that waste, like extra foam or nuts and bolts you don't need, or the biological waste. We have to return them somehow. So that's kind of like our garbage pickup, our garbage truck. Whenever a vehicle comes up, will be filled up and disposed of in its way. Yes.
So these systems must have a lot of similarities to what goes on some of these long range submarine trips.
Yes.
Has any of the technology flown back and forth between?
I don't know how to answer for sure, but I'm sure that how they're designing it is similar. The differences that we're going to have here is the microgravity issue. So for example, they can have just a tank of water, and it's all going to the water's still all going to sink to the bottom. Whereas, have you guys seen the astronaut videos of them playing with the water bubbles? It's not just a drop, which is why we can't have a shower. If you were to have a shower, you would just enclose the astronaut in a bubble, and they would drown. And so there's things like that we have to deal with how do you do it. So the same principles absolutely are still being done that kind of way. It's just probably a much different design, and probably much cheaper, because you don't have to have some of these things that we do. And also a submarine can more easily be brought up for maintenance, or have maintenance done on it maybe.
Well, they don't want to bring them up for 9 months.
Well, but these are not coming down, and so you only have 6 people that have to manage, the workers, hands-on in the whole space station. So you need to stuff.
Right, they can electrolyze that. They can take the salt out of water.
They can take ocean water in.
It's true.
Yeah.
They can definitely inject stuff out.
Right.
Yes, so same concepts, absolutely, but in terms of exactly the same thing, I imagine they're still done very differently. Yes.
So very interesting, thanks. Especially the special anecdotes, something breaks down, that's not something that you can find easily. Do you know if there is any incidents of the fire or other, the incidents, emergencies?
Not that I know of. They may have had a couple. I mean, that's part of, we have a lot of electronics and stuff there, so I think from when I've worked here, I think I heard one time of a false alarm, which is always good. In terms of actual fires, I can't think of one, but that doesn't mean it didn't happen. But every single system, if you have a computer and anything that could catch on fire, you're going to have some kind of suppression nearby.
Did I hear that your degree is in mechanical engineering?
It is.
So how did you ended up doing this?
So a lot of the people that work here, it's a lot of mechanical and a lot of chemical. And I'm sure you can see a lot of the chemical, but since I'm more on the mechanical side, since it's just the things turning, boiling water, it's much more in my expertise. I've learned a lot on the job with the chemistry of everything, just from the experts, which is really good to.
So
have
making
available.
devices to do those operations?
Yes, yep. So all of the design of the urine system, I'm trying to think, some of it's been divvied up with the contractors, and I'm not sure exactly how much with the water processor. Some of the oxygen generator was done here, was actually designed here at Marshall with our designers and built here in our big machine shop. So there is a lot of, mechanical, making the hardware. Yeah.
Quick question, I guess. When you form water droplets, and I've been working on this, but anyway, is that forming bubble first and it become water droplets? Is that how it's supposed to happen?
Well, I call it a bubble, but that's probably just the terminology that I'm using because it's just that round drop. To me, it's like a water bubble.
And what happened with the bubble that contain microgravity condition?
So you just mean how does it work in the microgravity?
Yeah, the bubble.
Yeah, well, so just because of that surface tension, you can go and look, and I'm trying to think of who's done the videos before. I can't remember, but you can just go onto YouTube and look for, water on ISS, and they'll take like those bags and they'll squeeze it out of that tube, and you just see the ball of water, and that surface tension stays together, and they can just make the little floating ball. So it's just the surface tension. If you tap it and that surface tension breaks, you'll see other little beads of water that'll fly off, but it's just the surface tension of the water. And that's what they use again to make that the espresso cup. It was how do you use that surface tension? How do you design a cup so that the surface tension stays together and can be used as a cup would be on Earth?
The reason why I asked all these questions really was what the submarine is supposed to do is create this what we call printing electronics in space. And we have this nanoparticle conductive ink. And we don't know their property and characteristic because there's no literature that ever done this type of, and we would try to look at all different angles. And because they're so small, the water droplet is actually maybe 1 million times bigger than what we're talking about here. That's what I was asking earlier, because we were thinking that maybe when they come out, we jet it out with aerosol jet, the droplets, it will, at gravity, it will probably come bubbles first.
Probably.
And then we can, using the conductive ink, then we can print electronics. But I don't know all the details of it. So
I imagine there's a lot of research that's been done just on water on the space station, so that may be something that you guys would be interested in, even though it is bigger. Maybe it'll have similar properties. That'd be something you guys could take a look at. That's really interesting, though. I mean, yeah, printing stuff is kind of the future. Everyone wants to print everything, so which is really exciting. People ask us in our system, what can you print? And I'm like, well, what can you print? But that's going to be something that we can use on Mars and stuff like that. Yeah, that's really exciting research to
I'll
look at.
help you out.
Okay.
So in terms of the thermal fluid systems, can you talk to where you guys are taking advantage of heat recovery opportunities, or where there might be some good ones that you just haven't looked at yet?
Yeah, so one of the big ones I mentioned how we boiled the urine. We're not adding heat because that would be a really big power source that we have to have. We have a vacuum pump, and so we're pulling the pressure down. But still, with our distillation system, the way that it works, it's kind of like a washing machine that spins. And so the fluid travels down that wall. You get the urine, the water is coming out and being sucked away. Some of it escapes, and so we have to have heaters around, not to add heat to the fluid, but to try to drive the fluid that escapes back into the bowl. Right now for the urine processor, that's our biggest use of power. It's like 50% of our whole system, and that's the only place that we really have something like that. So we're looking at ways to how can we just even like just stop fluid from escaping so we can reduce our power. We've also looked at some of the things, we've learned that our vacuum pump works a lot better when the fluid is cool. But it's on the outlet of our distillation assembly, so that you have that steam that's still hot. trying to figure out how to, if we can work like some kind of exchange in there that we can cool that fluid before it comes in with the inlet, if there's a way we can have them next to each other. And actually in the distillation itself, told you there's that bowl. There's 2 layers to that bowl. So on the inside is where the water is evaporating out, and on the outside of it is where it's condensing. So you have this latent heat exchange that's going between that wall to drive it around the system. Those are the big ones we're thinking of.
I mean, your humans are producing 600 to 1,000 watts just being there, so,
Mhm.
I mean, what's happening, anything with the HVAC system, you know?
I don't. That would be more in this area. That would be at Johnson, so I couldn't speak to that. But you could there's probably some literature, NASA literature out there that would answer your question.
What's the question?
That she was asking about dealing with the temperature and people, already giving off heat, if how that's
Can you
balanced.
talk about the atmosphere in the space station?
The
What are
atmosphere.
the components in the atmosphere in the space station?
Well, they try to keep it very similar. I think it's a little bit higher in oxygen than it is here on Earth, but
More than 20% or something?
yes.
Well, that's because the pressure is lower, right? There's like a curve that you have to sit on. If you drop
Yes.
the pressure down, you increase the amount of oxygen.
Right, and so that's also one of the things that dealing with when they put their suits on to go out and do EVAs, and they have a time where they have to adjust to the new pressure of the suit. Looking at Mars, they're also looking at how can we reduce the pressure in the habitat so that to get to the suit and go outside, they don't have as long of a wait time as well. Yeah, so that's kind of some of the stuff that's being worked in our exploration, where I said we're putting all of these different air things, systems together. We have them in one of those containers with 5-inch thick walls so that we can bring the pressure down and see, it's not going to implode, and we can see how they can react with more oxygen and lower pressure and balance all those kind of things for future.
I actually had a follow-up question, a little bit totally unrelated. What do you do? Can you speak to what you do to astronauts if they get sick up there, like they catch the common cold, or?
I can't, because that stuff is kept very hush-hush by the medical community.
Okay.
At Johnson, any kind of medical stuff is not at all really talked about. Because it's very private. It's private information.
Well, I mean, I just think like even if they accidentally got like a foodborne illness or something, I don't even know how that would happen.
Yeah.
Because it's a contained environment, so you would think the bacteria would be lower, and you don't have 3-year-old kids running around,
Yeah.
Stuff like that.
I would say more of a concern. So if there was a process issue in the food, then maybe that could be, but the standards are pretty high. I wouldn't expect that. I would expect honestly more of an issue to be like having a kidney stone. And how do you deal with that on, in space? So that's something that the medical group would, whether they walk them through it or bring them down. I mean, if something was really serious, there's always a way for the astronauts to get off of space station. So if there was a big issue, they would bring them back. They wouldn't keep them out there. But if it's something that they could work through with them, via their phones. I imagine that that's what they would do, but yeah, that stuff's kept pretty tightly under wraps in terms of that stuff. But I'm sure they have procedures for everything that you could ever think of. Because their whole focus, right, is the same as ours, keeping the people at the center and making sure that they're happy, healthy, and can do their job.
Maybe I could address your comment, but not from the point of view of the space station, but I know people who spend winter over at the South Pole for the ice cube experiment as well as the whole. And pretty much, people going there are certified not to be sick with the cold because they're in isolation in New Zealand. And then when they do arrive, it's such a closed system that there's no way a cold could, like a flu, could be generated.
Yeah, that's what I was thinking, that it would almost be next to
closed
impossible
system
for that to happen.
in the South
It's a
Pole.
closed system, but you still have,
Right, but if somehow some of the hardware was contaminated, that would be another
But they
thing.
probably have standards for that too, so.
They do.
Those are
They
all
do.
radiation treated,
Yeah.
food going to the South Pole. So it must be similar.
Do you have any separate water treatment system for, say, laundry and?
If we have a habitat, we would. Right now, their clothes are disposable.
Oh,
So they wear them for a week. Again, you get back to the trace contaminant control, and then they put on their next set. You know, they have to wear them for so many days because they can't do like we do, where they just have all these clothes and you can throw them in the wash. To develop a laundry for space station in the microgravity environment would be, I imagine, very difficult and very costly. So I'm sure that's why it's just, oh, we'll just throw away the clothes. But for going to a habitat at Mars, say, there will have to be something. And so when they were doing the initial overall water testing, that was actually something that they were looking at. They had been testing different soaps and things like that. And you could go, you know, after you worked out, you'd go shower, have a little shower. And they would collect that soapy water. But, you know, you had to have no foam. That kind of stuff. Because right now the astronauts, they just do like sponge baths with a washcloth to clean themselves, right? And then we evaporate that water and the system continues. But for something like if you could have a shower and the water's being collected and going, or if you could have laundry, that would you know, fit into this somehow. Right now the architecture just isn't there, but it would be processed in some way, whether you need to add something else to remove the soap, or if the water processor could handle the soap. Those kind of things I'm sure are being considered as to what that architecture will look like, and hope maybe we'll have some other fun stuff to develop. Any other questions? Everyone having fun?
I assume the urine recovery system and processing, you have a lot of pipes and maybe miniature pressure vessels and pumps and so on. In their material selection, does microgravity play a role? What difference does microgravity make when you're doing your designs, when selecting your materials?
Yeah, so in terms of materials, the microgravity isn't the issue, this acid is. So this acid, they did some tests and they had some like stainless steel little pitot tubes, and they took it out and it was just eaten up with holes and everything. So our limiting factor in terms of material selection is really the pre-treat that we're putting in. So everything that we use a lot of titanium. There's a couple other materials, but titanium is one of the big ones that we use for our hardware because it won't be eaten through. That also makes the system more expensive and more difficult to machine everything because you are having to use titanium instead of, you know, just making something out of aluminum. But that's really our limiting factor. In terms of microgravity, we don't have a lot of, at least in the urine processor pressure vessels, we have a lot of bellows, kind of like accordions. So that gets rid of the air, ideally. You know, it'll fill up and stay water solid as water comes in and out.
Just, for ECLSS group, what is the new big task for EM2 exploration mission 2 when they launch vehicle to Mars with man?
The biggest thing right now, I would say, is getting that 50% of the oxygen, and then across the board, how to, because the astronauts will be gone for, you know, say a mission of 3 years. So we need to try to make sure that our systems last for 3 years with minimal maintenance. That's one of the biggest things is reliability. We don't want, you know, we're going to have all these systems. You know, you don't, right now we can, oh, that thing broke. We have 1 or 2 spares that are up there, so they can just change it out, and we'll send another one up on the next flight. Since it's going to be so far away, we won't have that luxury. We're going to have to make sure that they last really at least 3 years.
So reliability rather than scalability. Just
So scalability will be another thing, but from what I've heard, I haven't heard, okay, your system is this big, now it needs to be this big. So those are some of the other things in terms of yes. And also if you know that, okay, this certain component isn't going to last 3 years, so we're going to need to send another one up, you need to make sure that the astronauts have easy access to it, and they're not going to have to take apart everything just to get to that one little part. Or some of the things on our hardware right now, the astronauts just couldn't do in microgravity. It would just be very, very hard. There'd be a mess, you'd have acid everywhere, and that's not a good day. So, okay, this is going to break. How can we redesign the components just so they can access that one thing and replace it. So the maintainability and the reliability are some of the big things, but yes, depending on what kind of volume that we get, the scalability of things will also, so maybe that's at the third. It's critical, but it's still probably secondary to making sure things last.
So knowing some breakpoints that has happened before, improving that area for better
Yes.
reliability, that's.
Yeah. Yeah, so we're doing a lot of that right now, of looking at what are the weaknesses in the system and how can we address them. And then with that, because like I said, ISS is a great test bed, how can we fix them and send them up and test them on ISS before we send them to Mars? And especially for going to Mars, everyone wants to be very cautious and make sure that we know what's going to happen. So we've learned the lessons we need to learn on ISS so that we're good to say, yes, it's good, go and send it, and we don't have to cut a mission short or do anything like that. Yeah, good question. Anything else? I don't know how much time we have.
The atmosphere on the space station is controlled temperature-wise and so forth?
Yes.
Just like an air conditioning system?
Yes, they have an air conditioning system on station.
And it gets the heat from the solar rays or
Yes, I believe
whatever
so.
on the station?
Yes, I believe so. I'm not sure if they have any other, if they try to capture anything else from, heat generated by the racks. I think most of their power like that is captured from the solar arrays, from my understanding at least.
Any other questions for Jennifer?
Yeah, I always heard that the minerals in the water, naturally occurring minerals, were healthy.
They are.
So
They
why,
are.
why wouldn't you all add minerals or ensure that minerals are in the water? Because you said everything is out of the water.
Yes, so they can add them in different ways, like maybe if they take supplements that they take throughout the day or adding them to their food. I think that really just it increases the complexity of the system. But if you can handle it outside of the system, that can be easier to manage or cost effective.
One a day vitamin. One a day vitamin.
That's right, yeah, take your one-a-day vitamin and you're good to go. Yep.
And last thing, I know what fluoride, that's it, fluoride's in the water here, but
Yeah,
that's
thinking
supposed
of the
to be.
future, long trip like Mars, and you want to keep people happy, you could put some happy juice in the water.
Some happy juice in the water, they'll be good to go. They'll be good to go. Yeah, again, I think that same kind of thing, all those minerals that they need, their diet, from what I understand, is pretty, strictly managed, and they got their flock of nutritionists making sure that they'll be safe. One of the things for space station, though, is they are only up there for 6 months. So, I mean, they're definitely doing everything. Astronauts are like the most taken care of people because everyone's looking out, right, for every single thing to make sure that you're as healthy and happy as you can be. If you're going for 3 years, things like that will definitely be a big concern. So I imagine they've learned a lot. And one of the things that happened, I think, within the last couple of years is they changed to a low sodium diet because that was also interfering with our system because if they have more sodium, they're putting out less water. So that can help things like our system and help their body. So I know they've learned some things like that. I'm sure they are things also as well as the fluoride. And I mean, I'm sure they have some like in their toothpaste and things like that. They have some access to it. Anything else? Well, it's great talking to you guys. Appreciate it. Thank you.
Any questions about the program, anything else? You'll be getting a note from Rachel about how, when we close out, what to do with your badges and so forth, and anything you've latched onto while you were here that you need to leave behind. And we will be having a sort of a going away luncheon, and we'll let you know where that's going to be.
Did everybody sign in?